Now we're going to talk a bit about slope. Slope is the steepness of a line. Slope is a ratio. It's the ratio of vertical change to horizontal change. Another word that we use that could represent slope, or I should say phrase, is average rate of change. Slope is average rate of change. And then look at this, of y, vertical, with respect to x, horizontal. Slope can be defined as rise, vertical, over run, or we use this delta y, delta. That delta symbol means change in. And you'll notice here we have change in y, vertical, over change in x. Okay, so slope, if you're talking about the steepness or the average rate of change, you're going to be setting up this ratio of vertical in the numerator to horizontal in the denominator. Y with respect to x. Rise over run, or just change in y over change in x. So if we look at formally defining slope, what we need to recognize is that in order to define slope, we need to be given 2 points or 2 ordered pairs. Now, you'll notice that my x, y ordered pairs, this first one is x sub 1, y sub 1. That just means these represent point 1, and this x and y go together. And then x sub 2, y sub 2, that represents point 2. And again, that x and y belong together. So, for example, if I was using colors, I could say x comma y, the green point, and x comma y, the blue point. But without color, we need those subscripts to help us understand what we are looking at and how to keep those x and y's grouped together. So if we are given 2 unique points, point 1 and point 2, we can define slope, and remember we already mentioned this, slope is defined by the variable m. We'll say that slope is the change in y over the change in x. Well, the change in y would be y sub 2 minus y sub 1. And then the change in x would be x sub 2 minus x sub 1. So the difference of the y values divided by the difference of the x values. And so you'll notice both of my second coordinates from my second point and my first coordinates, those are kind of matching up. They're lined up and they're organized. So I could also write this. I could say, or this is the same thing as y sub 1 minus y sub 2. And if I switch the order with which I'm subtracting, then that would be x sub 1 minus x sub 2. Right? So either of these works. It doesn't matter which point is point 1 or point 2. It just matters that when you're subtracting, you say green minus purple, or 2 minus 1, 2 minus 1. But essentially what we have here is our definition for slope. Right? Now, slope is the steepness or the slant of a line. And again, when we're dealing with a word problem, slope may represent the average rate of change. One thing to keep in mind when we are graphing, if a line has a positive slope, it will travel up across the page. It will be increasing from left to right. However, if it has a negative slope, the line will fall from left to right as you draw across the page. We generally always draw left to right. The way we read in America is left to right, so that's kind of the way we draw. So we just want to make sure that we keep that path of slope, the direction that it's going, in mind when we start talking about graphing, which we'll get to in a little bit. So the first thing we're going to talk about here is just actually finding the slope given 2 points, and then also identifying slope from some linear function. So let's look at 2 examples of finding the slope. Our first example, we're given two ordered pairs, pi, -3, and pi, 2. And we're going to use the definition of slope that we just defined or wrote out on the previous slide. So looking at this, I have two ordered pairs. I'll call this my point 2 merely because it comes second, and I'll call this first one point 1. Right, so we have an x and y from point 1 and an x and y from point 2. And if I were to set this up, I would say m equals the change in my y values, that's going to be 2 minus -3 over, we'll have pi, take away pi. Simplifying that, I've got 2 minus -3, that is +5, 2 plus 3 over 0. Are we allowed to divide by 0? The answer is no. So this slope, the slope of this line, is undefined. And that should make sense because if we looked at plotting these points, my x value would be over here at pi, about 3.14. I would travel up 2, so about right there, and down 3. If I looked at plotting these, what kind of line would I be drawing? We'd get a vertical line, and the slope of a vertical line is undefined. This vertical line is x equals pi. So the answer for that first example is undefined. Let's look at example 2. In this situation, we are not given ordered pairs specifically. One thing you want to notice though, or recall, I should say, is that f of x equals y, right? This is function notation. F of x means y, or f of x equals y. So in this situation, I can write two ordered pairs. X is 1/2, y is -5. X is -7, y is 1/3. So if I went to find the slope, I'd set this up, I'd say m equals my y values, I'll say 1/3 minus -5 and -7 minus 1/2. So y minus y over x minus x, noting that I did the subtraction in the same direction each time. At this point, we just need to simplify this fraction. So getting a common denominator in the numerator, that would be plus, and we would have 15/3. I now have 16/3 divided by, here I'll have -14/2, getting that common denominator. So minus another 1/2 is -15/2. When we think about dividing with fractions, now sure, we can probably type this into our calculator and get the correct answer, but what if we don't have our calculator? What we need to remember is that division is the same as multiplying by the reciprocal. So we copy, change, flip, and I can rewrite this as 16/3 times -2/15. And then we can multiply straight across. So -32 over 45, which is not simplified. This fraction does not reduce. Now, if you're going to rely on your calculator, I encourage you to make sure you can type this correctly in your calculator. Depending on your version, you may need to be very careful with your parentheses and organizing. And I really, really beg you right now, just make sure you can simplify something like that and get this answer in your calculator using your parentheses correctly. So that is how we can find slope from definition. Given 2 points or 2 points in function notation. I'd like to look at just one more example. And I know I said one example, but we're going to look at just a couple really quick types of examples for identifying slope as well as the y-intercept for given a function. Here, we're given y equals 5/2 x minus 3. Remember, the equation of our line is going to be y equals mx plus b. What you want to note is that that m value represents your slope and the b value represents the y-intercept. So m is the coefficient of x. For this first example, m, my slope, is 5/2, and my b value is -3, which gives me a y-intercept of 0, -3, because a y-intercept is a point where we are crossing the y-axis, and x will always be 0 at that y-intercept. So given a line, we can identify both the slope and y-intercept. For a following example, we now have y equals -x plus 2/3. Now remember, the coefficient in front of x is going to represent slope. So in this case, slope, and it looks like there's no number there, that slope is actually m equals -1. Negative x means -1 times x. And my b value being 2/3, that means my y-intercept is the ordered pair 0, 2/3. So again, we have found the slope and y-intercept. Now in both of these previous two examples, m came first and b came second. So here for our third example, we have y equals 1/2 plus x. What I want you to notice is that x comes second here. So we could very easily reorder this and write this as y equals x plus 1/2 using the property of commutativity. And what we'll see in this situation that m is the coefficient in front of x is +1, and my b value is 1/2. So my y-intercept is the ordered pair 0, 1/2. So my point in that situation is just to make sure you're noticing that the slope is always the coefficient in front of x, and then your b value is the constant term. You need to pay attention to the order. Let's look at another example. In this example, we're given y plus 4x equals 10. Remember, we need y equals mx plus b in order to identify the y-intercept and slope. So again, this needs to be rearranged. Using the additive property of equality, I'll move that 4x to the other side. I have -4x plus 10. Here, my slope, m, is -4, and my y-intercept comes from +10, so I have 0, 10. Let's just look at one last example. For this last example, I have 2y minus 8x equals 5. Again, we need to get this reorganized. So first thing I'll do is add the 8x. So I've got 8x plus 5 on the right side of the equation. Then I'll divide everything by 2. That gives me y equals 8 divided by 2 is 4x. And then plus 5 divided by 2. In this situation, my slope, m, is +4. And my y-intercept, don't forget when you're dividing by 2, everything on the right side gets divided by 2, so that becomes 5/2. We have a y-intercept of 0, 5/2. So I hope that helps you understand identifying slope and finding slope given 2 points a little bit better, in case you already didn't. As always, please email me with any questions or concerns because I am here to help. Good luck.